Welcome to another edition of Random Road Cuts here at Hoover Dam in Nevada, right along the Colorado River. So here we are looking downstream at the Colorado River and the new bridge they built just downstream of the dam. But there's Hoover Dam there, and we've got some road cuts here along the little access road on a not so busy Sunday. Thanks for joining me. I'm Geology Professor Shawn Willsey, and we're going to take a look at some of the rocks down here at these road cuts. If you're new to this series, the idea here is we just, like it says, we just find a random road cut, pull over, look at it, make some observations, maybe make some interpretations, and see what we can discover together. So thanks for joining me. So the road kind of winds down through these, I guess, somewhat pink, beige, peach colored rocks, and there's plenty of access points along the way. There's some pullouts here. I'm just parked up around the corner, and we're in a little spot here where there's a little place to get off the road. So let's just start with these rocks here, start with some observations, and then we'll walk around the corner where we can get and look down into the canyon a little bit here. So a little bit of road cut, a little bit of canyon observations. So let's start with the rocks here that are here in outcrop. So we can see the pink colors here, and when we do these random road cuts, it's always nice to start with the regional context. And here in southern Nevada, boy, you can just get a little bit of anything. You can get metamorphic rocks, volcanic rocks are quite common, even intrusive rocks or magma that cooled underground, and even sedimentary rocks. So anything is potentially on the table here. As we look at these rocks up close, we can see there's some particles within the rocks themselves, so clasts of other rocks such as we see here. You can also see there's a lot of voids, right? There's a lot of holes in the rock, and a lot of those look like those previously had rocks in them, right? So maybe there was some other rock there that possibly weathered out. If we come up in here, we can see a couple more little pieces here. So again, we're trying to decipher what kind of rock type we're looking at with this particular outcrop. And everything I'm seeing so far with the clasts and some of these holes in the rock, so it might look like it's sedimentary at first glance, because you can see that there's chunks of other rocks in here. But remember, we can also get other processes that can produce this type of texture within the rocks. And so let's look at a couple other spots as well and see if we can figure out what's going on here. So no obvious layering in the rock. It's a kind of a hodgepodge mixture. The textures are somewhat chaotic. The class sizes, I think the biggest thing we've seen here is maybe fist size or so. We can maybe come down here. There's a little bit bigger outcrop right here, or it's just above this hairpin turn along the roadway. We can see what we can see in here. So yeah, some more of these clasts. When we look at the specific clasts themselves, they look to me like they're volcanic in terms of their texture. I can see little crystals in there, fairly small crystals, so that indicates that the magma cooled slowly. There's some nice fresh exposures here. And in here, what this really looks like to me, in looking at all these observations, I don't have it in the sunlight, but this looks like tuff. So this is a volcanic ash that's been compacted and welded together. And whatever explosive eruptive event produced this tuff also was throwing out or possibly incorporating larger chunks of rock. And that's what some of these clasts are here. So these larger pieces we see in it. This pinkish color as well is a very common shade or hue that you often see in volcanic tuffs. I don't know how old this is. A lot of the tuffs or volcanic activity in this area in southern Nevada would most likely be Miocene, so anywhere from like 25 to 15 or so million years ago is probably a good ballpark number. Sorry if it's a little loud here. And as we come around the corner, we're starting to see something else. If we get down low here, oh, this is awesome. This is exquisite. Move a couple rocks. Notice down here, we've got a nice polished face and there's lines running through the rock. So on this surface here, now notice those lines, if I come over to this side, the lines don't penetrate into the rock. They're literally just on this face here. So this is a fault surface, and these lines are called slicken lines, or sometimes the surface is called slicken sides. And these lines indicate that when this fault moved, with these lines oriented this way, that the fault moves side to side. So either this block that my hand is on moved in this direction, or else it moved in that direction. And then therefore the opposite side, which is now gone, moved in the opposing direction. And if we look to the next little face that's oriented more or less the same way, we can see more of these things. Super polished, somewhat corrugated, and then these nice fault, these striations running through there. Again, these are called slicken lines. So we have a volcanic tuff, pretty big unit here. We don't know how high it goes up the walls of the canyon, but it's pretty substantial here in terms of its thickness, likely hundreds of feet thick. And we might be able to figure that out as we head over towards the canyon and look down. A lot of these voids in our tuff could actually be places where there was blocks of pumice. So the pumice is somewhat soft and will tend to kind of break down and end up producing a lot of the voids we see here in this volcanic tuff. Oh wow. Okay, so check this out. This is really awesome here. So now we've got several faults here in front of us. So we've got a nice slick surface right here. So you can see how polished this is. And there are some crude slicken lines showing the movement of the faulting. This kind of transfers over to this face as well. You can see it's also oxidized. So there's been some maybe water that's moved through it that's actually cause the irons to oxidate, the iron oxidation to occur. Sorry, long day. And so you can see some of that staining there. If I turn this way, you can see another small little fault plane with more of these slicken lines this way. And then the biggest feature here, as we look up this big steep slab, is you can actually see that this is also another fault plane. So there's also striations here running up and down this surface, this big fault plane. So we've got multiple faults that have cut this tuff, this volcanic tuff, at some point in time after the rock was deposited, and we can see or sense the direction of motion. So this big fault plane has movement up and down. So this would be a dip slip fault, or a fault that's moving things vertically. Around the corner we saw side to side motion, or what we call strike slip movement on the fault. Let's work our way down a little further. There's a lot to digest here, and we're kind of at a little narrow spot, although there's a little bit of a berth here for walking. No stopping anytime, so I don't know, maybe we need to keep moving. Now we've got a totally different rock type. We have a nice contact here with a darker rock. It's a little bit faulted. The bottom contact kind of comes down and then it shifts down again. So there's some small faults there cutting it as well. And in looking at this darker rock, definitely also looks volcanic. It has small little white crystals in it. It's darker, so its composition is maybe a little bit more mafic, more magnesium and iron rich than the tuff itself. And so this could either be, now if we look at the contact closely, there's some interesting things to see here as well. Notice that we've got the dark rock here, but right at the contact we can see some red, some discoloration of the tuff above, right along this contact. So what this suggests then, because we have igneous material here and igneous material above, right? We've got the ash layer here and this other igneous rock here. This could be a dike or a sill. So this, if this was magma that intruded the tuff, then we would expect as the heat from that magma permeates into the tuff that you might see some discoloration. And that's actually what we're seeing here. Again, just an interpretation, just a possibility of what we're seeing along this contact here. So let's head down a little bit further so we can see that contact kind of going up the outcrop there. And now we're into this gray, more massive unit. This gray unit's a little bit more beat up. There's a lot of these reddish brown oxidized faces in it. Now there's another contact. So now we're seeing another sharp contact here. And now as I keep stepping this way, we go back into the tuff. It looks like this is the same tuff that we saw before, more or less the same color, has the kind of holes in it in places. So we've got a nice sharp contact running right through here, and we're just under the bridge here. So let's stay close to the wall. I think it's pretty good idea to, if you're going to come here, come at a time like I'm here where it's pretty slow. More slicken lines, so you can see more of these polished surfaces, and the lines in this case are running sideways down the fault plane. So now we have movement that wasn't purely up and down, and it wasn't purely side to side. So this is what we call oblique slip. So the movement was down, and in this case down to the right, but not purely up and down. So we've got a lot of fault movement that's taken place here, and in the Las Vegas region there's faults that are related to the San Andreas that are strike slip faults, or what we call, there's a shear zone there where the things have been pushed side to side. And if we look up, we can actually see that same contact that we just saw around the corner between the gray, darker igneous rocks and the tuff right here at this hairpin turn in the Hoover Dam area. So let's head a little further, and I'm assuming, yeah, so now we can actually see that contact coming back down, because that contact is dipping or is oriented, in this case, down to the east. And now we can see it coming down this way, and then it's coming down right here to road level. And you can see the rocks on this side are darker than the ones to the left. That's about as far as I can back up and show you here with the road. But yeah, this looks like the same material, gray with some small crystals, so the crystal size is fairly small. So it could either be a lava flow, or it could be a dike or an intrusion, but probably was an intrusion that came pretty close to the surface because the grain size is pretty small. And then here we are back at this upper contact. So really at this hairpin turn, we've been able to see the upper and the lower contacts in both places. And here we're seeing similarly kind of some of this reddish discoloration here. So one possible interpretation is that this contact represents the intrusion of magma that then baked or oxidized a little bit of this tuff unit just above. Let's see. So we'll go down a little bit further here and wrap this up, but pretty nice. Didn't know what to expect coming down here, so been pretty impressed with the rock type so far. So more of the tuff, somewhat massive, not seeing a lot of the little faults in here that we saw before. And probably if we had some sunlight on this, be a little easier to see maybe some of the little ash particles. Here's a nice oxidized surface with more of the slicken lines. You can see the striations running parallel to the rock hammer here, running this way. And then also if I run my hand across this, it undulates a little bit. It's going up and down, so it's corrugated. And you often see that with fault surfaces, that they are not perfectly planar, but they're sometimes kind of like cardboard, a little bit corrugated. Okay. Oh wow, here we go. So here we have another section of this dark rock cutting up through the tuff. And I'm gonna back up here. Oh, there's no cars on the road and give you a quick look into the canyon, but then we'll go back and look at that. And we can see some more of these over here, right? So here's another dark dike, potentially another dark zone of rock cutting through the lighter colored rock. Another one over here. So these actually project across the canyon, but this one here is really nice. And now I think with this exposure here, it definitely looks like these are intrusive contacts, right? These are not lava flows stacked up in with the tuff. We can see it's quite thin at the bottom. It thickens and then it changes its thickness. So this was an intrusion of magma that cuts through these rock layers here. Really nice. I'm gonna head back across before these cars come, just so we can look at it in a little bit more detail, and then we'll get out of here. I don't recommend coming here when it's busy. This is probably not the place to do your roadside geology when it's this busy. Go down a little bit further. There's the contact up high. Yeah, this is definitely a tuff through here. And then, yeah, it looks like it's more of the same tuff without that intrusion cutting through it. Particles in here. You can see some of the clasts in here. So very explosive event. Whatever produced this tuff was definitely a violent and explosive eruption that could throw out and propel this much ash and fragmented rock. And then we'll go ahead and wrap up this kind of longer Hoover Dam random road cut. I think we can sneak across the road, get a nice look down into the canyon, and then we'll call it good at that point. So sneaking across. And then there's a nice view downstream. Perfect day too. It's December. Weather's just perfect. Lighting's really good. We'll get a nice view of the dam as well. So looking down and over here to the, I guess that's the northeast or east at Hoover Dam. And I'll let you look up all sorts of great history lessons on the building of the dam in the late 20s and early 30s, and the harnessing of the Colorado River, all sorts of ways you could tell that story. But we can see some of these intrusions across the canyon. We can also see they're not lined up. You can see this one over here is terminated, but then there's a couple more over here. So it looks like there's probably some faults that have offset these. In fact, we can see a great fault. Wow, this is perfect. Right above this building here, I'll use the pointer here, but right here there's a fault that cuts that dike, that intrusion, and it's faulted up onto this side, and it comes down, and it's faulted up. So there's a series of faults, normal faults, that have offset it on this side of the canyon. But great view downstream of Black Canyon here in Nevada, right near the Nevada-Arizona border. So wow, just super sweet. So there you have it, friends. Hoover Dam, little geology along the road cut. We started up here along the roadway. You can see the retaining wall there, and we came down, and then there was a hairpin turn here that we walked down. So maybe not a good place for you to come and walk, just because when it's congested, there'd be a lot of folks there driving cars. It could be a little spicy. So, but thanks for joining me again. Appreciate all your support. Hope you enjoyed this episode of Random Road Cuts. Again, Geology Professor Shawn Willsey, and we'll see you next time from another road cut in another random location.